testing. Okay. Welcome back. I get everybody to sit down. We're going to get going. Can everybody hear me back there? Can you hear me? Okay, if you're standing around talking, you now need to sit down. I know everybody wants to catch up after reading week, but maybe after lecture. Okay, so I hope you all had a good reading week. How many people started on milestone 2? I know at least a few people did because there are questions. Okay, so be proud. If you start on milestone 2, it's not a bad thing. So put your hand up if you start on milestone 2. Okay, so a reasonable number. How many have looked at either went to or looked at the tutorial 6, the walkthrough of milestone 2? Okay, so if you didn't attend and you haven't looked at it, go look at it because it really does help get you going. We're going to talk today more about graphics, and at the end of this lecture you should have everything you need to do milestone 2, well, except the parts you have to figure out on your own, and there are some of those. Don't leave it to the last minute. It's a bit more open-ended than milestone 1, so most students find it quite a bit of fun, but not if they leave it to the last 3 days and then try to cram it all in, so that's not a good technique. Okay, so we talked before reading week about the first thing you need to do this map visualization. We need to get a graphics window open, and I showed you this code. Okay, so you have a function that has to be called drawmap because our unit tests are also going to call it, and that function has to get the graphics going. And you're going to have some boilerplate code. So we went through this in the tutorial, but basically this kind of boilerplate code says use the default window layout that we've created for you and get my graphics window going. This code is not such boilerplate. This code is basically creating a coordinate system. So I've created a coordinate system here. I've created a rectangle from x equals 0, y equals 0 to x equals 1100, y equals 1150, and I've said that's my coordinate system. So for the part of the graphics window I'm going to draw on, that's the coordinate system I want to use. And then this last line here basically says in the drawing area of the graphics layout we've given you, we called it main canvas, 2 things. It says set the coordinate system to that rectangle I just created. I called that rectangle initial world. I want you to use that. And it gives you the name of a callback. It gives ece297, the graphics library, the name of a callback function, and I've chosen to call it draw main canvas. And that callback function will be called whenever the graphics need to be redrawn. Okay? Remember, the graphics package knows when a redraw is needed. I don't know that. But the graphics package doesn't know what to draw in like this city visualization part of your user interface. So you tell it, well, when a redraw is needed, call me. Call this routine. Okay, so then I'm still in that draw map. We call this application.run. Application is the main ece297 object. And I call this run method. And I can choose to pass it 4 callback functions. Okay, so these are the names of functions. If I don't want to use a certain callback, I can pass in null pointer instead. Initial setup is called right after the graphics window is created. I can write code in this callback function that I've said is called initial setup to do more stuff. Maybe I want to create some additional buttons and use UI elements. I can do it right there. I can't do that until the graphics window is displayed. So that's why I have to put it inside. If I want to do that, I got to put it inside this callback. I might want to do something when the user clicks the mouse in that graphics area where I'm drawing the city. If so, I give the name of that routine to application.run. I also could choose to maybe do something when the person just moves the mouse in my graphics area. Maybe I want to highlight things automatically or do tooltips. I could do that. And I might want to do something when the user clicks a key again, in that graphics area, okay? So ece2gl is going to create some buttons for you. It'll manage clicks on those buttons, but it doesn't know how to manage mouse clicks, mouse movement, etc. in the area where you're drawing your city. If you want to do something when those things happen, you have to register these callbacks. Hopefully that makes sense. Okay, so these are all the names of functions you write. From 243, have you guys learned how a function really gets called? What happens when you really call a function? Anybody want to volunteer on this? If you volunteer after, if you take a shot at this, because we're doing like linkage between courses here, advanced concept, I'll give you a chocolate bar after class. So everybody want to take a shot of what really happens when you, at the machine code level, right? The assembly or machine code level when you actually call a function. So C10, I think you're feeling good about 243, so go for it. What happens? Right, so it's, so I'm going to repeat that so everybody can hear it. But you basically said the assembler makes an instruction to go to the subroutine. So depending on the exactly which processor it is, might be called branch to subroutine, might be called jump to subroutine. And what that does is it just goes to a certain memory address and starts reading instructions from there. That's really what it means to call a subroutine. Okay, so that's how these, sometimes students are confused by what the heck are these callbacks? Like, what does this mean? You're passing the name of functions into another function. Well, the name of a function to a compiler actually just means a memory address. It knows where it put the instructions for that function. So what it actually passes is the address of the function. And when ece2gl needs to do something, for example, it knows the mouse button has been clicked and it basically goes, I'm supposed to do something, I'm supposed to call some function. It looks at, well, what address did you pass me? It'll actually do a branch to subroutine to go to that address and start executing instructions there. So that's how callbacks work. They're not magic. The compiler is interpreting these names just as addresses, storing them so that it can call them when the appropriate event happens. Does that make sense? So you don't really need to know that. You could just memorize, I pass it the name of the functions, but that's what's happening under the hood. Okay, so this is what ece2gl's kind of main window looks like. So there's a bunch of buttons here on the right-hand side that were actually automatically created, okay? You don't have to write any code to create that. Well, most of them. This one I actually created in my example. But basically, most of these buttons are created automatically by ece2gl. In the example application we give you, and you should run this, we created a few additional buttons, like this test button, but you can see how we do that. It's pretty easy. Then we have this big area, and that's the draw main canvas, or the main canvas. This is where you're drawing your city, okay, where most of our work's going to happen. All of the stuff in here was drawn by, this is the example program, it's all drawn by code that we wrote in the example program and you will write for your mapper. There's a little area down here where you can put a status message. So there's a function to make a status message. And this proceed button is kind of special. Proceed means return from this application.run function. So you could be in this function for a long time, right? Person's clicking on buttons, zooming in and out, etc. When the user clicks proceed or hits the X button to close the window, control actually exits from application.run and goes back to your program. Okay, so your program is kind of not going to move forward beyond application run for a long time. And these other buttons are used for zooming in and out, panning, and so on. And you can also use the mouse to do that. Okay, so this I said all of that. Okay, so the most complicated function you're going to write for milestone 2 is this screen redrawing function. And you don't have to redraw this stuff. You don't have to redraw that stuff, like the status bar or the buttons. ece2gl knows how to do that. But you do have to redraw this. It doesn't know what you're drawing there. You're drawing a city, it doesn't know that. Okay, so that's going to be a pretty complicated function. If you look at the code I used to set up the window, I said that the function to redraw the screen, my callback, was called draw main canvas. So now I'm going to show you, what can you put in that. You can't change the function signature of a callback, okay? Because ece2gl is going to call this function by pushing a renderer into the stack. You're learning this in 243. When you call a function, you take all the inputs it needs, you stick them on the stack, and then you jump to that address. Okay, so ece2gl is going to basically put a pointer to an object called a renderer that you can use to draw on the stack. It means that your function needs to be written to expect that. So you must use this function signature. Inside the draw main canvas, now you can do anything you want. Okay, so what do? Well, you're probably going to have a lot of setting drawing attributes. Okay, so attributes are how will you draw? What's the color? So here I'm saying let's use the black color, and that's a named color in ece2gl. But I can also say let's use a color red, green, blue is 0, 0, 0, so that's also black. And you can actually specify an optional fourth parameter, which is how transparent is it. So a value of 255, these are all 8-bit numbers, actually means opaque. So this set color actually doesn't, these two set colors actually do exactly the same thing. They both say draw in opaque black. One of them is shorthand, one of them is more explicit. They both do the same thing. You could make things semi-transparent. So if I change this 255 to like 130, I would kind of see half of the background bleed through and half of what I drew on top. So that could be useful to make things look nicer. Opaque drawing is a bit faster. Well, it's actually about twice as fast. So if you don't need transparency, like you're just doing it because you thought maybe making it slightly transparent would be fun, well, it will make things about twice as slow. So you usually only do it when you need it. And the reason it makes things twice as slow is the graphics engine actually has more work to do. It has to take the color underneath a pixel, the color you're asking for, has to blend them together and then draw that pixel. That's actually a little more work, well, it's about twice as much work as actually just changing the pixel. Does that make sense? Yeah. You might have to turn on your mic. Or maybe I have to turn on your mic. So let's see, A09. Okay, your mic is on.
So where do we get access to the conventions of the colors?
So this is all documented in multiple places, okay? So the header files for ece2gl, and I talked about this a bunch in tutorial 6, so go watch it. And also look at the example program that I'm about to demo you, okay? The example program is another form of documentation. But the ece2gl header files are heavily commented, so they tell you all the functions, they tell you exactly how to call them. When you're in an IDE, it'll actually generally, as long as it's functioning properly, it'll show you those comments when you start typing the function name. So that's how you see is this RGB or not? We commented it. If you go into Quarkus, on the ece2gl Quick Start page, there's one more form of documentation, which is basically hyperlinked HTML documentation that comes from the comments. There's a tool called Doxygen that can take comments written in a standard format and turn them into web pages. We wrote the comments in ece2gl in that format, so you can also go to Quarkus, and right beside the ece2gl Quick Start guide is this web documentation. Click on any of the functions, click on any of the objects, it'll tell you all about them. What it's telling you is exactly what's in the comments, but it can be easier to read. Okay, so good question. Okay, so a couple other attributes. I can do things like I can make the lines narrower or wider, so I can set the line width. Line widths are set in pixels. I can say I want my lines to be dashed, okay, and I have to look in ece2gl to see, well, this is like a defined constant. It's a certain named constant that says I want an asymmetric dash. Okay, you look at ece2gl's comments and you see that's there. All of these attributes are what's called sticky. It means they stay until you change them. So I just set the colors and line widths, and now I might draw 1 million lines. They'd all come out black, they'd all come out 3 pixels wide, they all come out dashed. And I'm also going to draw primitives. Okay, and there are a lot of different primitives in ece2gl. So I can draw lines, I could fill rectangles. Okay, so in ece2gl we use the word draw to mean essentially outline, and we use fill to mean it's a shape. Okay, so you can fill rectangles, you can fill polygons, and so on. And go see the various sources of documentation I just told you to get familiar with, well, what's there. Okay, so I want to do a quick demo. So how many people have downloaded and run the ece2gl example program? Okay, so quite a few, but not everybody. So I'm gonna, for those who haven't, this is hopefully an advertisement that you will now want to go download it. So let me, what I want to do is I'm going to take that example program, we're going to quickly change it to to draw a thick blue diagonal line across the middle of the screen on top of our other graphics. Okay? So let me move this over to my other machine. Okay, so you can see that. Let's get rid of this. Okay, so this is the ece297 example program. It's basically a bunch of code that is going to bring up a basic user interface and draw a bunch of stuff to demonstrate what you can do. All the code is in this one file, basic application.cpp. It's like maybe 500 lines long, and it's heavily commented. So you can go through this and see, well, what can I do? This is maybe the easiest form of documentation. I'm not going to go through all that right now, but basically, there's a bunch of code that is the boilerplate I just showed you to get the window on the screen, okay? And I basically showed you this code already. And the most important thing is that we've set our redraw function to draw that main canvas, the graphics area. We called it draw main canvas, so I'm going to show you that function in a second. And we set our coordinate system to be basically what I showed you, from 0, 0 to 1,000, 1050. Okay, so let me go to this. All right, so it's not working yet, so I'll just go to it another way. Okay, so here's my main redraw function. And all it is helper functions right now. Okay, so you can't really see much very much interesting because it's all helper functions. Your redraw function for milestone 2 is going to get really long. So this is how you should write it, right? It should just be calling helper functions. And the helper functions are often going to be calling helper functions. If you start writing a bunch of code in this routine will get enormous. Your TA will be sad. Your TA will reluctantly take marks off, okay? So don't do that. Here's one of those helper functions. And I'm not going to go through it in detail, but you can see it's doing exactly the same kinds of things that I just showed you, right? It's setting colors, it's drawing text, it's filling rectangles in, etc. Okay, so let me build this and run it so you can see what the graphics looks like. Okay, so there's my, there's the graphics. I'll make this slightly bigger. And this is what all those helper functions are doing. They're just demonstrating you can draw lines of different thicknesses. They can be dashed, they can be solid. You can draw text, you can rotate the text. You can draw partially transparent things. You can fill in circles, etc. And over here, a bunch of these buttons are made automatically with me doing nothing, but we made a few extra buttons. So we created this test button. You can look, it wasn't hard, right? We just called the function create button to do this. And when I click on it, it basically just updates what's in my, this status bar, okay? So it said test button pressed. And we show you a few other UI elements you can create right now. So here's a simple drop down. You can create dialog boxes, you can create pop-up messages, etc. So read through this example to see how do I do all these things. These are all things that ece297 gives you. And as I zoom in and out, so I can click on these buttons, I'm zooming in and out, my redraw function's being called every time I do that. And as I move around the graphics by pulling with my mouse, dragging them, my redraw function's being called over and over again. My redraw function actually, I'm not going to show you all the details. We went through this in tutorial 6. My redraw function just kind of draws the same thing all the time. ece297 is changing how the drawing calls I make map to the screen so that it zooms in or out. So zooming in and out, panning, it's all pretty easy. You'll notice this one thing here. Up here it says screen coordinate fixed loc. That's not moving. Okay, so you can choose to draw on an alternative coordinate system called screen coordinates, which are pixels, and that won't move as you zoom in and out. So sometimes you want that for specific stuff. You can also do animations. So if I click on this button, what's going to happen is ece297, let me zoom out actually so you can see that better. But basically, I'm drawing a bunch of stuff with no user input. Okay, so you can do animations too if you wish. And see if there's anything else. I've registered callbacks for mouse movement. So down here you can see my callback for a mouse movement just prints out where the mouse is. So as I move the mouse, you'll see there's lots of stuff happening. That callback's getting called many, many times. If I click the mouse, a different callback gets called. Okay, so it tells me where the person clicked. And again, I wrote that callback. I told EasyGL to call it. And if I hit the keyboard, actually, I don't think I hooked up the keyboard. Okay, so the keyboard isn't actually, I didn't make a callback for that. That's basically it. I can even get rid of buttons if I want to. So, okay, so let's see. My little challenge was to change this. Let me go find this again. Okay. Okay, so I'm back in my draw screen routine, draw main canvas. That's my redraw function. And I said, let's see if we can write code to basically draw a thick, dark blue line that goes from the bottom left of that graphics area, my main canvas, to the upper right. Okay, so, again, I'm going to resort to bribery. Come after class if you answer this. I'll give you a chocolate bar. So anybody want to take a shot at what should I write? It's not very many lines of code. What code should I write to make that happen? Somebody's got to feel confident. Okay, so I see A09. Let's go to you. Okay, so what should I say it really loud? What should I write? Well, so actually, you're right. I should write this as a helper function, but because it's in a class and I'm in a rush, I'm going to write it right here. But totally right, bad style. I should write this in a helper function. Okay, so I'm going to need draw a line. So you access all these things through the renderer. So if I go back here, the renderer that was passed in is called G. It's a pointer to a renderer. All your drawing functions for setting attributes, drawing primitives are member functions of a renderer. So I'm going to go G dash. And when I do that, I need to do draw line. And I was hoping that I would get like some tooltips, but my IntelliSense is not working yet. Draw line takes 2 points. What would you make these 2 points?
The lower coordinates.
Right, so the lower coordinates probably like 0, 0. I said that was my coordinate system. Okay, so I said it was like 1,000, 1050. Okay, so we'll do that. Okay, so that's draw a line. Anything else you want to add? So we are going to add some more. Okay, so anybody else want to help them out? So that is drawing the line. I said I want it to be dark blue and I want it to be thick. What do you think?
Yeah, I saw that.
Okay, so G, so it's again part of the renderer. All right, now I'm getting tooltips, which is good. Okay, so set color, and so I could use, there is actually a named blue, but I'm just going to do this with red, green, blue. So my red should be 0. My green should be 0, and I want dark blue. If I went 255, that's going to be a very bright blue. If I went 0, it's going to be black. I'm going to go maybe, I don't know, 120. Okay, so kind of half on blue.
And then you want to set line width.
Right, so let's go set line width. And you can see I could have set the dash style if I wanted, but I don't want to. This is in pixels. You know, the screen usually is maybe at least 1,000 by 1,000 pixels, maybe 2,000 by 2,000. What would you set it to? Make me an offer. 100? Okay, so do 100. And okay, so let's build this and see what it looks like. Okay, and it looks pretty good, all right? And it's, okay, it drew on top of my graphics. Why did it draw on top of the other graphics? What do you think?
Because it's called the latest.
Yeah, it's called last. So order matters, right? I want this on top, I draw it last. If I wanted this to be semi-transparent, well, maybe I'll do that. If I zoom in and zoom out, so, you know, you can kind of see the size of the line changes, but because line width is pixels, its thickness isn't. Okay, so where it is changing, but its thickness isn't. If I wanted its thickness to change too, then I could draw a polygon instead. In that case, the whole thing would scale. Okay, and maybe one last thing I'll show you here. If I wanted to make this partly transparent, I just add in this fourth parameter. Now 255 is transparent, so maybe I'll make it half transparent. Or 255 is opaque. That's called the alpha value. So I'll make it half transparent, and now you can kind of see through it. Okay, so I like this. This looks nicer. So I strongly recommend you look through that example program, because it's probably the easiest way to learn how to use the graphics library. Okay, so I just did that. Okay, so any questions so far, or is it all pretty clear? Sounds good, looks pretty clear. Okay, let's talk a bit about coordinate systems and level of detail. So I told you ece297 is layered on top of other graphics libraries. One of them is called GTK. There's also a couple of rendering libraries we're using. They're all based on pixels. Okay, that's actually the conventional way that graphics libraries work. And in pixel coordinates, I don't know why they chose this, but it was chosen many years ago in the early days of computer graphics. The top left corner is 0, 0, and the bottom right corner is like the biggest pixel that your screen can show. Okay, so if my screen had a resolution of like 900 pixels wide, the bottom right would be 900 pixels by 619 pixels. Okay, so that, if you draw directly in GTK, you draw in pixels, which is kind of a pain. Why is it a pain? Because your map's not in pixels. You'd wind up with coordinate transformation code all over the place. So yeah, it's actually inconvenient to draw a lot of things in pixels. So what we do in ece297 is we define what's called a world coordinate system. So that means it's a coordinate system you choose. It's your world. We went over this in tutorial 6, but a very logical coordinate system is, we've told you in milestone 1, if you look through it again, how to project from latitude and longitude and a circular or spherical Earth to a flat projection in a certain region in meters on the surface of the Earth, okay? So that's a very natural coordinate system. If you take the map coordinates in latitude and longitude, you convert them into this XY coordinate system that is on the surface of the Earth, you can draw in that, and it's much more natural. You don't have to worry about how many pixels this is. ece297 will take care of it. So set that as your coordinate system. And I showed you how to do that. You make a rectangle. I've been calling that rectangle initial world, and you give it basically 2 points, the lower left and the upper right, and it'll make those two coordinates kind of map to your entire drawing area. And these are actually reasonable coordinates for Toronto, but you're not going to hard code those. You go look at tutorial 6, you'll see how to compute them in a better way. Now, the world coordinates you asked for may not match the aspect ratio of the screen. These world coordinates are a bit wider and not so tall compared to this drawing area. So ece297 adjusts what's visible on screen so it doesn't distort your graphics. So you basically may get a bit more coordinate space in one direction than you asked for, but that's fine. And it ensures that your graphics won't be distorted, like 1 X unit equals 1 Y unit. Does that make sense to everybody? Okay. And I already mentioned this, but basically, it's built into ece297 that you can zoom in, you can zoom out, you can left-click the graphics and sort of pan or drag them around, and you don't really have to do anything for that. Your screen redraw function can just draw things the same way all the time. The way it works is that inside ece297 is something called a transformation matrix, which is its mapping from your world coordinates to the actual pixel coordinates of the screen. And as you zoom in and out, or you pan the graphics, that transformation matrix is changed. You can draw your graphics the exact same way, but they will just show up differently. So if I clicked zoom in, what would happen is, let's say that, let's go back one. I'm drawing my whole map. I click zoom in, basically ece297 updates the transformation matrix, so now only this part of your map will be visible. Only a sub piece will map into the window, and you'll see that piece bigger, and the rest of it won't map to the window and is gone. Does that make sense? So panning and zooming, easy. What does this mean? Yeah, your draw main canvas function, that screen redraw callback, can always draw the whole map. You don't have to worry about is that on the screen or off the screen. You can just draw it all. Now you can say, well, isn't that going to slow me down? And it does slow you down a little bit to be drawing stuff that is off screen. You are wasting a little bit of time, but not as much as you'd think, because the very first thing ece297 does before it draws anything is it checks is it completely off the screen, and it does that with pretty efficient code. So it pretty rapidly figures out this is not on the screen. What that means is generally your map will get faster as you zoom in, even if you don't do anything to try to make it faster. As you zoom in, more stuff is off screen, and ece297 throws it away quicker. Okay, now sometimes, I showed you in that demo, I had some text in the top left corner that wasn't moving. Sometimes you want things that don't move around as the person zooms in and out. So for example, well, maybe I'll start with an example. Let's say I wanted to have a legend that showed the scale of my map. So I'd like this to be in the upper left corner all the time. I don't want it to move around as the person pans. I don't want it to get bigger and smaller. Well, I don't want it to kind of go weird places as the person pans the graphics around. And in order to draw those kinds of things, you can draw in screen coordinates. Screen coordinates means pixels. Okay, again, start to top left is 0, 0. Bottom right is like the biggest pixels visible, the maximum pixels that are visible for this drawing area on your current screen. And yeah, could be useful for a scale or maybe some other types of overlays. To make that happen, it's another attribute. So you call a function called set coordinate system. It's another member function of the renderer. And you can ask for screen coordinates, which means I want to draw in pixels. You'll draw in pixels until you change it. When you want to draw in world coordinates again, you change it back. You say, I want to draw in world coordinates again. So you basically have the option, right? You can draw things that automatically scale and move around as the person pans and zooms, and you can draw things that never move. Okay, so one of the other challenges that you're going to have in milestone 2 is dealing with level of detail modeling. So we basically said, we want you to show us all the streets. We want you to show us if they're one way or not. We want you to be able to show us their names. That's a lot of detail. So, but we're saying you have to show it to us somehow. Okay, so there has to be a way to show this to your TA. So if you're zoomed way in, you can see a lot of detail. You can see small streets, you can display street names and so on. But if you zoomed way out and you draw every detail, it's just, first it'll tend to be slow, but also it's going to tend to be a mess. Okay, if you draw every street and every name and you're zoomed way out, well, Toronto has, I think about 20,000 streets. So if I draw 20,000 names, it has it has tens of thousands of points of interest and so on. If I start drawing 100,000 pieces of text on the screen, I'm not going to be able to read any of it, right? It's just going to be a giant mess. So if I'm zoomed way out, I shouldn't be trying to draw everything. So you're going to have some code that reacts to. You have to control this somehow. So as part of what you're doing in WD1, one of your challenges is how are you going to deal with, you must be able to show all the detail, but you're also not trying to overwhelm your user. So that's actually one of your challenges. So in WD1, you're exploring what are some options to deal with that. Well, you're exploring usability and responsiveness, but I guess I'm pointing out this is going to impact that, right, if you just overwhelm the user. So we give you some utilities that can help you. You are going to have to write some code and think about this to make it work. So to draw text, you first set a font size. Okay, so I've said I want 10-point font. Okay, points are like a printer's term. I don't know where this came from, but they mean 1/72 of an inch. So 10-point font really means 10 divided by 72 inches high. That's not world coordinates, right? That's like an absolute coordinate system. It doesn't, so text sizes don't get bigger and smaller as you zoom in and out. They're going to be whatever you asked for. The way you draw text is you basically pick a point. Okay, so I've taken a point in my world coordinates here, and I've said I want to draw this string, and it'll be drawn in a 10-point font centered at that point. Now you can also change, ece297 has attributes to say I want it right justified or left justified as well if you want. But this is going to center awesome street. It's going to be 10/72 of an inch high, centered at that world coordinate. Okay, so let's say that I'm zoomed out quite a bit, and this is a relatively small street. Then that size of text could actually be much bigger than a street, which looks a bit silly. But if I do this for a whole bunch of streets, I'm in a loop drawing everything, it's going to look worse than silly, okay? It's going to be street names all over top of each other, and it's going to be a giant mess, okay? So we don't want to do that. So one of the tools you have to avoid that is a pretty easy one to use. So draw text always requires two parameters, okay? It requires the point where you're going to draw the text, in this case the center point, and it requires the text itself. But it actually has two other optional parameters, okay? And you can make optional parameters in C++ by giving them a default value. So if you go look at the source code for draw text, you'll see we've given default values to these last two parameters, which means you don't have to specify them. Okay, these last two parameters are an X bound and a Y bound. What those bounds are is if the text is going to occupy more than that amount of space on the screen. Okay, so if you're drawing in world coordinates, then my logical coordinate system for this assignment would be meters on the surface of the Earth. So these bounds would be in meters on the surface of the Earth. And if the text was going to occupy more than that space in my world coordinates, I won't draw it, okay? So if I don't specify these, they default to huge numbers, which means I don't care how big this text is on the screen, draw it. But if I want to, I can say things like, okay, I know that this street is 200 meters long, and I'm using a coordinate system. My world coordinate system is in meters, so 200 meters is a perfectly reasonable length value. It matches my coordinate system. And I could basically say, well, I want to pass that street length in as both my bound X and my bound Y to this draw text routine. And what it means is if this text is going to occupy space on the screen that is bigger than 200 meters would occupy, don't draw it. It basically means if it's bigger than the street, don't draw it. Okay, so this is a pretty simple way that you can avoid drawing lots of text when you're zoomed out. As you zoom in, it'll actually draw again, because the sort of number of pixels that 200 meters maps to is increasing as you zoom in. So as you zoom in enough, the text will eventually actually pass this text and start rendering. So pretty easy way to make sort of text appear and disappear as you zoom in and out. Is everybody with me on this one? Okay, so A09, let's see. Yeah?
Does that mean like when you're zooming in the pixels, the lower bound, upper bound, does it change?
Okay, so the pixels, okay, so the question is, as you're zooming in, do the pixels change? The actual screen coordinates, like the pixels of your window, don't change. Okay, so screen coordinates only change when you resize the window. Okay? But the world coordinates, which is what I'm using here, I'm drawing this text, I haven't shown it, but you draw most of your stuff in world coordinates. So I've set my coordinate system at the very start to be world coordinates, I'm drawing everything in world coordinates. So these are going to be interpreted not as pixels, but as world coordinates. And basically, if I'm zoomed way out, 200 meters in my world coordinates might map to 1 pixel, right? Like it's tiny. If I zoom way in, the 200 meters might map to the whole screen width, like 1,000 pixels. Does that make sense? So what EasyGL does is it figures out how big is this text, and then it compares it to that size in your current coordinate system. So that naturally takes into account how zoomed in and zoomed out you are.
So when you're drawing the text here with the street lights, what are you telling the world, what are you telling the world for? So you think that I can draw it with the world coordinates is like...
So this is all being drawn in world coordinates. So when I don't show anything, it's basically in world coordinates, because the vast majority of your drawing, depending on how you do your map, maybe all your drawing will be done in world coordinates. It is the default coordinate system in EasyGL. If you don't specify anything, you're drawing in world coordinates. Does that make sense? If not, maybe ask me some more after. Okay. So basically, if I change my code by just adding in these two other parameters, and I set them intelligently, I set them to the size of the street in my world coordinates, basically when I'm zoomed out, this won't happen. That text just won't be drawn. If I zoom way in and this street starts filling like half of my screen, the name will suddenly appear. That's one helpful function, right? You can make your text kind of do this, how big am I test before it draws. Other helpful functions for level of detail are get visible world. Okay, so these are all member functions of the renderer as well. Get visible world, it's basically the opposite of what we did when we started up, when we made that initial world. Get visible world basically returns a rectangle whose corners correspond to the coordinates in your own coordinate system, the one you asked for, which again I'm recommending is meters on the surface of the Earth for your city. It gives you the corners of your coordinate system that are currently visible on the screen. Okay? So if you called this right after you start the graphics, it's just going to give you back the same initial world that you specified. But if you've zoomed in 10 times, you're going to get back a rectangle that is much smaller in terms of the coordinates, because only a small part of your screen is on, only a small part of your coordinates are visible on the screen. Does that make sense? So this lets you see how much of my coordinate system is on the screen right now, okay? You can also ask for get visible screen. Get visible screen does the same thing, but it's just pixels. So it's actually just telling you how big the drawing window you're in is in pixels, which sometimes can be helpful. And there's another function called world to screen, where you pass in a rectangle in your own coordinate systems. So maybe you say this is like 10 by 10, which in our recommended coordinate system would be 10 meters by 10 meters. And it'll convert it into screen coordinates. It'll tell you, well, that would map to a rectangle that is 30 pixels by 30 pixels. And you might go, well, that's pretty big, I better draw this. Or it might tell you that maps to a rectangle that is like 1 pixel by 1 pixel. And you might say, that's pretty small, I'm not gonna bother. Does that make sense? These are all heavily commented, so if you're kind of going, I don't know if I can remember all this, don't worry, I'm just introducing you to the concepts. You're gonna have to read the header file. This is how you can tell all of these functions, well, these two functions in particular are ways for you to tell, am I zoomed way in? Am I zoomed way out? And you can be more precise than that. You can actually figure out exactly how zoomed in you are. And you can use that to make decisions about what should I draw and what should I not draw, so that I don't overwhelm people. But that at some point, I can actually show my TA all the detail. Okay, that's not the only way you can kind of avoid overwhelming your user, your TA, right? You have the ability to create buttons and do all sorts of other controls, but it's gonna be one of the things you use. Okay, so I also talked about, that's all about drawing. I also told you there are other callbacks to respond to user input. So one of those functions that you can specify, one of those callbacks, is the one that is called whenever the user clicks the mouse in that kind of main drawing area, that main canvas. Okay, so again, we have to use the right function signature. ece297 is going to call a function with this name, and it's going to push these parameters on the stack, so you can't change this. You can change the name, because you're going to tell ece297 what its name is, but you must take these parameters. So one of your parameters is a pointer to the ece297 application. That's because to call pretty much anything in ece297, you need an object. So we pass you the object. You're passed a pointer to something from GTK called an event button event. Basically, if you want to, you can actually look at what this points to see is the left button click, the right button is shift held down, so you can get more information about the mouse. And then the most important things is you get the X and Y coordinate where the person clicked, and you get that in world coordinates. Okay, so it's in your own coordinate system because that's usually the most convenient. What set this name? Well, way back when I called application run, the second parameter is the name of the function that should be called if the user clicks the mouse in your drawing area. So these have to match. Okay, and in the example application I showed you, you can see an example of this. It basically just shows you how to print out where did the person click, and also how to check is the shift button shift held down, etc. So you can look at that as another form of documentation. Okay, graphics libraries, including ece297, do not know what you've drawn, okay? So you draw a bunch of lines, polygons, circles, whatever to make your city look nice, and as soon as ece297 draws something, it forgets about it, okay? It actually understands these buttons. Those are a bit different. They're called graphics widgets, so those it kind of understands, but all this drawing here, visualization, it has no idea what you've done. So when you click the mouse, it can't possibly figure out what you're clicking on. Instead, it can call your callback function, which we just registered, and I showed you what it is. Your callback function, if you want to highlight, for example, an intersection, like we did in tutorial 6, you need to figure out what intersection the person clicked on. And you have to do that by going through all of the intersections and figuring out which one's closest, okay? So that's the basic technique. When somebody clicks, you have to figure out what does it mean. And a common thing is, well, whatever's closest is what they clicked on. I have to write code to figure out whatever is closest. And then I need to take some action, store some state, etc. We went through this in quite a bit of detail in tutorial 6, so see that for more detail. And you can create more buttons, okay? So this ece297 creates most of these buttons automatically, but this test button it didn't create. If you look inside of our example program, you'll see we created a few extra buttons. It's pretty easy. There's just a create button function. And each of these buttons you create this way, you give it a callback function. One of the things create button wants is it wants the name of a function which will be called when the user clicks on it. So that's so you can do something, right? You decide what does it mean when the person clicks by writing a function that does something that's useful to you. I already mentioned this. We've given you a little status bar at the bottom. You can put a message there. You just do that by calling it a function called update message. The message will stay there until you change it. And you can do more. So this is all you need to do for milestone 2. But if you look at this and you say, I don't like this, so I chose this UI layout, right? And some of my TAs are like, man, that is like a late 80s UI layout, right? So I am a child of the 80s. So if you look at it and you go, I don't like that UI layout, you can modify it. Okay, we give you all the source code for ece297. You can change anything you want. To change the UI layout, you don't have to change source code. You just have to change a resource file that we've called main.ui that specifies the layout. And I'm going to show you how to do that in the tutorial this week. So if you want to change the layout, we'll go through how you can do that using a layout editor. You can add additional functionality. Some of the things like pop-up dialogues, ece297 gives you a very easy to use function. Some of the more advanced UI widgets, you have to go to GTK, like to the underlying library, because it has a lot of widgets and ece297 doesn't expose them all. If you want to do any of those more advanced things to make your UI look more powerful, nicer, read the GTK Quick Start Guide. So you don't have to use those direct features, but if you want to, we've given you a guide to get you started, and we'll talk some about them in tutorial 7 this week. The other thing we'll talk about in tutorial this week is how to tell how fast your code is. Multiple techniques to find slow code. The reason for that, and I'm going to do that by demonstrating our graphics and basically speeding them up. That's also important because one of your challenges in milestone 2 is to try to have a reasonable redraw speed that's going to affect a user's impression of your application. If it redraws very slowly, it'll feel laggy. You want to know how can I figure out what's taking time? So that's the second part of tutorial 7. How do we find slow code using tools like profilers so you can speed it up? So I strongly recommend you go to the tutorial this week as well. And I think, unless it's a mistake, G07 has keyed in a question. G07, do you have a question? Or is this an accident? Okay, it's all clear? Okay. I think we have one question from A09. So it's also an accident, or?